All right, let's go through simple connections. Yeah, in this class we gonna talk about simple connections. It's gonna be like really just the basics. Like I said, connections in steel is very important. As you can see, the beams and columns you selected, they don't just come together magically. You have to actually connect them. Like you have welding here, you have some bolts in here. So we're gonna talk about those. The limitation here we're talking about is really we're trying to just tell you what a single or a group of connections, like a group of bolts, like those four, how much load each one of them can take, and how much a group can take if everyone is kind of taking the same amount of load. There will be other type of not simple connection designs, which will involve maybe when those bolts are not loaded equally, they're loaded by a force with a moment lever arm, so it's a combined force. And also later, if you really want to get into like seismic designs and the connections, how to consider their ductility and everything, uh, that's not so simple connections. But today we're gonna just focus on the individual connectors and the individual welds. See how much it will take. Also, in this video, we're actually not gonna go all the way to strengths of all connections. We're gonna introduce the connections we're gonna do, and then we're gonna talk briefly about the strengths of the welds, and then we'll leave the strengths of the bolts in another video. Okay. So the connection chapter in the code is chapter J. So let's take a look. In fact, I always like to make mark. So let's just zoom in on actually what this connection really look like, this chapter. So I'm assuming you're gonna, have a code with you while you listen to this. You can read the general provisions. In fact, it's quite long, but we're gonna really focus on the J2 weld and J3 bolts and threaded parts at this point, because all that you need to know about simple connection design and strength check, about welding and bolts and threaded parts, they are in those two sections. The other sections, they are some other details on connection details, and some of them talk about very specific things like bearing on concrete something, or embedment anchor inside the concrete. We're not going to talk about those, but if you run into those situations, you can go to them. And we actually have been here before, if you recall. When we do block share, we actually were in J4. So what J4 does is, if you think about a connection, let me change a corner. You think about a connection, say if you have something, two bolts, hanging some other stuff, then it's in tension. We actually already covered J4 with the connected parts. That's the connecting elements or affected elements, which means the failure of connection is not caused by the bolts here. It's actually caused by either yielding, fracture, or block shear of the connected elements. So we kind of already did that. So that's why when we do block shear, we actually went to J4 to find the formulas. But today we're gonna actually just focus on talking about the failure of those boats. Or if you're doing welding, we're talking about the failure of the welding. Okay, so that's J2 and J3. So let's go to the next one. First of all, when you talk about connections, you want to know what we're talking about. Like how many things we need to consider. In steel, there's mainly three types: bolts, welds, and rivets. But rivets, as you can see shown here, is pretty much discontinued. Like nobody's doing them anymore. In fact, there's no provision in ASC current steel manual about rivets. If you want to, not that you want to, why would you want to? I mean, if you have to do it, that means you're doing some old buildings, some forensic engineering on some old bridges where they actually have rivets. You need to dig out and try to find another special code for rivets, which is referenced in this ASC manual, but the details are in a different book, so you can do that. We're not going to talk about that. So we're going to talk about boats. For boats, there are mainly two types. There is a typical, what we call ASTM A307 boats, which you can see it's like right here. You'll be able to see 307 on its head. Or you'll see high strength boats, which is they divide them into group A, group B. The main difference, I mean, if you think about them, you can think of them as this guy is made of a steel material that is ductile and soft. It's not high strength. So it can only be used in what they call snug tight installation. What does that mean is by definition, it is you tighten it with a nut to the best you can as humanly possible and with fingers. We call it finger tight. And then after that, you use a wrench to do a quarter turn. Then it becomes snug tight. The main mechanism of this type of connection, when you are slot tight to resist shear, is by this bolt itself bearing on the connected part itself. If they're gonna go into failure, it's gonna either be a failure of the bolt itself, so you shear this entire thing off, or it will be some bearing failure of the connected metal. If the metal is, you can think about it, if the metal is too thin, then you can have some bearing failure there. Group A and Group B high strength bolts, they are made of a different material, so they can be post-tensioned. In fact, a lot of time when you actually specify those are actually more expensive also. They are for what we call slip critical connections. This type of connection, they basically, I'll do a kind of a picture. Let's kind of explain that. So you have like two steel plates you want to connect together. Then you, let me change the color. You throw a bolt in, okay? Throw a bolt in. Let's consider, if this is the, say, high strength bolt, this is your bolt, and then there's a nut. What it does is that you keep cranking this guy. In the end, there will be a huge tension force within your bolt. Now, what this tension force, which we call pretension, does is that it creates a G. Okay, well, compression force between the plate. So if you look at this surface here, yeah, in between the two plates, they're actually under a huge amount of compression. So when you want to kind of separate those two guys, like in tension, you can't because there's friction in there, okay? So there's friction in there. This type of connection resists external force is actually through friction. You're like, okay, well, big deal. What does it mean? That means if the friction force is always there, in fact, those two pieces of metal won't actually move at all. You can think of even if, say, this hole which this bolt goes through is, say, oversized. Yeah, let me do that. It's oversized. See, this hole is actually not. It's actually this wide. It's wider than the boat, right? Like this hole is wider than the boat. Because of this friction, oh, come on. Because of this friction force, under those two tension, as long as the friction is greater than the tension, the boat won't even touch the side of the boat, like here, won't even touch the side of the hole. So the boat, all the boat can see is actually tension. It won't actually come in touch with the hole. So this we call a slip critical, which means, it won't slip. A slip critical connection, and it's not a bearing connection. The bearing connection is, different. The bearing connection to actually engage, if you think about it, if you don't have friction, and you have a boat. Oh, come on. Okay. If you have a boat that you need to resist those forces. Oh. Like this side of the boat will actually need to be get in touch with this plate, and on the top side, this side of the boat will have to get in touch with this plate, and they have to kind of bear together to create this bearing force to resist this tensile force. So this is called a bearing type connection because the boat itself does not have enough pretension to create the friction needed, like in this case. So this guy can be what I call snug tight, but the high strength post-tensioned boat or pre-tension boat has to be installed with a torque wrench or a special installation device to make sure that the boat is pre-tensioned to the needed tension force. The discussion about the two type of boats, you can actually read them in chapter J3, right? Because it basically just said A307 are permitted to do any connection unless pretensioning is specified. Yeah. So basically, as an engineer, in fact, you can actually achieve the same amount of capacity with either one of them. You can specify snug, tight connection to get, say, 500 kips. You can also do slip critical high strength connection to get 500 kips. It's a designer's choice. Of course, their design going to be different. They're going to cost differently. depending on the equipment and the installation technique and everything. But yeah, you have options. The high strength boat, you have group A. In fact, there's a whole bunch of like A boats. And group B, oh, in fact, yeah, I think I made a mistake. There's a group C, but if you want to read more, there's more for you to read. And also, there's actually a specific other additional, you want to call it design code, or you want to call it a design reference for those connections. If you want to read more, you can do that. One thing to kind of mention is you can see here under the high strength boat. That means like in fact the boats are actually permitted to be installed to the snug tight condition. So basically what this does is saying that if you have a Ferrari racing car, you don't have to always race like 150 miles per hour. You can still drive at low speed. Of course, you can race, you can get pretension, but you don't have to. Of course, it won't be a effective use of material if you do that, but if you have high strength boats, say if it's group A boat, and you only install it to be snug tight, then you should check it as a bearing type connection. How to do that we will talk about later in the next video, but yeah, now I'm just trying to let you know that. Okay, here's two type of boats. Normal boats, non-high strength or high strength. Normal boats, it can only be using the bearing type connection in a snug tight installation situation. High strength boats can do both. It can be snug tight or it can be pretensioned. Okay, so the next big one is welding, right? Welding, based on how you do it, there's mainly three types. There's groove welds, there's fitted welds, there's plug and slot welds. Okay, how do they look like? Alright, so this is groove weld. In fact, there's a whole bunch of them. If you think about groove weld, you could almost think like two pieces, they just get welded together head to head, and the welding actually reconstitute most of their cross section. That's what we call a groove weld. For the groove weld that actually goes through all the cross section, those are what I call full penetration groove weld. Then there could be some situations. For example, yeah, I think all those I showed here, they are actually all full penetration welds. But you can have a groove weld that's not fully penetration. For example, you have this piece, yeah, I'm exaggerating here, and then another piece, you want to weld them together. So how do you do that? You could do a full penetration weld. Then that means typically they will need to, like, you need to cut it like that, then cut this side like that. Of course, yeah, once you cut it, this part is gone, right? Then you have a kind of V-shaped gap where your worker is gonna come in and start welding. So what they'll do is that they'll weld the first pass, then they'll weld the second pass, the third, fourth. Yeah, depending on how thick this thing is, maybe yeah, I'm exaggerating. Maybe a couple of passes will kind of weld it. Then this becomes like your welded piece. This is a full penetration weld. But then you're like, okay, well, what does half penetration look like? So here's the deal. You have actually, yeah, let's get it red. Okay. You have you have two pieces you want to link together, but those together like just too thick. It's a hassle to kind of do all the way. So what they do is like, oh, okay, well, we're gonna like cut here and cut here. Oh yeah, maybe we'll cut here and then we'll cut also here. Now you can imagine like those parts are gone. So you're gonna have welds over there. But yeah, if you look at the middle, yeah, once everything get welded, you see a weld like here. You can see a weld like in here. But let's say in here, yeah, there's dusting. So this is what we call a partial penetration groove weld, and groove weld is pretty much those two types. Then fillet weld. The benefit is that you don't need to do any cutting. You look at the groove weld. I mean, like maybe with the exception of this one, which is like, I don't think people do this very often. Most of them you need to kind of cut and pre-cut the surface in some fashion. But fillet weld, you just butt those two pieces together and then weld along their, the angle they form. The fillet weld, there are a couple of terminology within fillet weld. The fillet weld is used mostly to connect two perpendicular pieces, but they can also be used to connect like this guy. You just do a weld here, do a weld here, then it can release tension. The fillet weld, there's a couple of terminology like the you can think of fillet weld as a triangle, like you said here. Yeah, like this side, like this face won't be like perfectly straight, but we typically just assume it's straight and ignore whatever is in excess of that. So you will have the kind of side of the triangle. Typically they are equal side. We call it leg. The root is really the inner point of that triangle, where you can think about this is where a fillet weld take roots, right? Then the face is what you see. Like this is the face, this is the face. Toe is basically where it kind of touches either side of the welded piece. Then the most importantly, the throat is actually the shortest distance from the face to the root, considering if it is a perfect triangle. Why I'm saying the throat is the most important? It is because when you calculate the strength of fillet weld, this is the number to use. It's not the face, it's not the leg, it's the throat. Because, we consider the failure of the fillet weld will happen along the throat. Okay, so that's pretty easy to understand. Then finally you have the plug weld or slot weld, where I actually don't think you'd run into this very often, but it could happen. Maybe they don't want to do a fillet weld here, or they don't want to do something here. What they do is they drill a hole on top of one plate and put it on top of another, then they just weld this full. So those are the plug and slot welds. 3 types of welds. And so what about their strengths? The strength of weld doesn't matter which one you are. It's pretty much a resistance factor phi times the nominal strength and times the effective area. The phi factor, depending on which one you are, it can be different. Yeah, some are 0.75, some are 0.8, some are 0.9. Okay, it's a little crazy. Then the nominal strength is the strength of the weld material, typically it is related to a kind of type of welding metal you use. All the welding metal, if you specify them, you specify this number, FEXX. That's the strength of welding material. And you can find them in the weld tab, which is in weld tab, which is part 8, table 8 through 3. So yeah, not that complicated. Basically, if you design weld, you have to specify this. Okay. Then the contractor gonna buy a welding material that has your specified FEXX to do the welding. And the nominal strength is not directly this. It's typically like 60% of this, or sometimes 70, sometimes 50% of this. We'll get to that. Then the effective area of a weld, there's a lot of ways to calculate them, depending on which one you are. But all the effective area calculation formula and the methods are defined in the corresponding chapters or sections of those 3 types of weld: J2.1, 2.2, and 2.3. Then you're like, okay, well, this is different, and this is different. This is like a little crazy. Like, how do I wrap my head around this? In fact, to do this, everything is summarized in table J2.5. That's why this guy is like very important. This table is almost like a index to how to calculate weld strength. So let's take a look. So this table is actually just 1.5 page. The first page, oh yeah, let's take a look at this guy. You can see there is like what type of weld you're looking at. The first big type is complete, or we say full joint penetration groove welds. In fact, for this one, for the most part, they just say if you specify this type of weld, which is actually expensive and have a pretty high requirement for welder. So if you want to specify those, you may want to just specify them to be prefabricated in the factory, because on-site to do full joint penetration weld, it's kind of hard. And it will involve additional inspection requirement, which will be very costly to your project. But if you're able to do that, in fact, they say, okay, you don't need to check it. If this is done correctly and pass all the checks, pass all the quality inspection, the strength of your connection is not controlled by the weld. The weld is always stronger. It is actually controlled by the base metal. Base metal, which means the things you're welding, The weld will not break. Those things you're welding will break first. So there's no calculation here. Okay. Then partial joint penetration. We'll use this as an example. You can see the first column is what kind of a load type, and then direction relative to weld axis. You're like, what does that mean? Load type, you can have tension, compression, tension, or shear, right? Then relative to weld axis, the weld is always like you can think of it as a line. Then that line is the axis of the weld. Like tension normal to weld axis, right? So in here, it'll say, okay, what do you need to check? You say you need to check the base metal, base means base metal, and you need to check the weld. Then, once you need to do that, what are the phi and omega to use? Omega, it is ASD, we don't do that, we do phi. So here's where you get all the phis, depending on the type of weld and then type of force, right? Like for the weld here, you have phi 0.8, sometimes you get here it's most 0.8. Then, what is the nominal stress? Like here, you see it's like 60% of FEXX, 60%, or in this case 90%, 60%. Then finally, effective area, how to calculate those? Of course, they're not gonna put formulas in there. They just say, hey, go to this section and read it, calculate it, and do that. The sometimes you need a filler metal. So this column is dedicated to that. Yeah, filler metal strength, what's required. So yeah, nothing fancy here. And then actually the first page is not that interesting because this guy doesn't require any calculation. This guy, you actually don't run into it very often, but you do run into very often. Is this half page? Oh, come on. Which is fillet weld. It's like 80% of the weld you're gonna do in steel design, especially on site. On site is even more. On site is maybe like 90% are fillet weld. And two things are very interesting. The first thing is like here you see all kinds of tension, compression, whatever. In here is just shear. And tension or compression parallel to weld axis. You're like, how about tension and compression perpendicular to weld axis? In fact, if you still remember, we talk about the fillet weld, they're gonna break in this 45-degree angle. In fact, no matter how you load this fillet weld, as long as your force is coming in perpendicular to the weld axis, we assume it's always gonna break along this line in shear. So that's why you don't see any other things here. It's just you just check shear, tension and compression parallel. Then we're like, okay, we're gonna just neglect it. We're just gonna check shear. That's it. And you have a phi of 0.75, 60% of FEXX. Then for the area, you need to see J2.2A. Okay. Then finally, you have a plug and slot weld. It's right here. Similar idea. So that's a very brief introduction on the basic connection overall and how to check strength of the weld. If you're interested, you can probably look at your textbook for some examples, but I'm not gonna require you in the exam in this class to do weld, but I will require you to do simple bolt strength checks using tables, which we will try to cover in a different video. So we'll close for now for this one. Thank you.